Hey, and welcome back for another episode of SHOWOFF CI CD Pipeline. I'm here today with Lee. Thank you for coming on the show today, Lee. Hi.
I appreciate the invite. Thank you.
Great to have you finally. It took us a while to get together, but we do both know each other. Our audience might not know you, so can you tell us a little bit about who you are, what you do, and what makes you happy?
Yep. Lee Gilmore. The thing that makes us happy, let's cover that first, which is family. That's what I live for. And obviously serverless. I'm a big fan of serverless. I've been in the industry now for about 23 years, I believe it is, working in IT. Started off originally racking physical servers and writing .NET applications for government mainly. And over the years, obviously, that kind of spanned through to cloud. So moved to EC2 and then eventually through containers to serverless. Back in 2014, built out a very large SaaS platform, which was great. You know, Lambda just came out at that point. I think it was towards November, December. And over that time, over the next year, we started building out this big application, millions of users on the system, hundreds of thousands of companies, very spiky traffic. So that was great. I think I just got the bug from then. And yeah, now that's my main role as a global enterprise serverless architect, working across North America, EMEA, working with amazing teams, building out these large serverless applications. And obviously AWS Community Builder, that's how we originally met. So yeah, we've been chatting quite a bit on Twitter, trying to get this organized. And also massive congratulations on the hero status. That's massively deserved.
Thank you so much, Lee. Yeah, that was unexpected, but it's great to have that title now, and I hope that I can really use it to help you and others, right? And keep learning, because today I think what we're doing is you're going to teach me something, right? This is really cool. What are we going to look at?
So today what I was going to cover is CDK Pipelines. It's not something that I actually use with the teams I work with, but something that came out was the CDK Pipelines AWS best practice that AWS brought out. And I looked at that and the use of CDK Pipelines, the idea of it, because I am a heavy CDK user, and just seeing how I could take that from, you know, this small application. It's got a client front end, it's got back-end services, and using that continuous delivery method, how can we create a pipeline that hits each of these different items that AWS covered as best practice? So things like load testing, SAST, DAST, all of that kind of good stuff.
Yeah, and that makes you a perfect partner for me. Because I'm working on an open source project to also make that kind of stuff available, but not only in CDK pipelines, but also in other building tools. And I can add that link to the show notes later as well. But before talking more about that kind of stuff, let's look at what you have prepared for today. And I think we're going to start with some diagramming, right? So maybe it makes sense that you can start sharing your screen and we just look at what you have.
Yeah, sounds good.
Okay, ready to go.
Awesome. So on the right-hand side, this is the AWS CDK Pipelines paper that was put together. And this talks about how you would do continuous delivery straight through to production. And for anybody that hasn't heard of continuous delivery, it's the idea of pushing feature changes regularly. You know, it could be 10 times a day. You know, there isn't kind of any kind of focus on that other than these regular kind of deploys through to production. And with that, it's typically trunk-based development, so based on your main line. And with that, you could imagine pushing continuously to production. There's a key focus on two areas, which is the testing aspect, making sure that, you know, what you're pushing through meets all of these different quality gates. And then there's feature flags. So being able to hide these from the customer until you're happy that the feature's complete, and then enabling that in the production environment. So it's essentially hidden in that environment in production.
So let me just chime in here with a short remark. That means we're talking continuous deployment here, So the way that I present it on my channel and my posts, continuous deployment is the piece where the software actually gets into your production environment, and continuous delivery is then the piece where you actually activate the features that you just talked about, right? With CDK Pipelines, we're rather focusing on the continuous deployment aspect of it. And the delivery is an aspect that is segregated from the deployment, is what you're saying, right?
That's right, exactly.
Okay, cool. Yeah, and this is all then supposed to be automated, is what you're saying?
Yeah, so the full idea is, how do you do this again with CDK, and very opinionated around TypeScript. So most of the teams I work with are full stack TypeScript. And what's really appealing with this is your front end could be React using TypeScript. You could have your pipelines written in CDK TypeScript, your backend services. So everything that you're doing here, the cognitive load is quite low. Developers are just working in one tech stack, typically with the same frameworks full stack as well. Things like Jest on the front end, Jest on the back end. So yeah.
Yeah.
So looking at this, kind of talking through it very high level, you can see you've got your local development, which is on the left-hand side. So you've got things like building the code, unit tests, code quality. So unit tests might be using Jest. Code quality, you might have things like ESLint in there. You might have Prettier to obviously make sure there's a particular format that goes through with all of your code. And things like CDK NAG. So actually having that run as the developer is actually doing the development before they actually push that to whichever code repository you're using. So I'm using GitHub here. You'll actually check at that point, shifting this totally left, the quality gate. So if we look on the left-hand side, very quickly here, we can see we've got Husky. So we've got pre-commit and pre-push. So as the engineer, the developer is actually pushing, you'll see that in here, we have in the package.json, down here, we are on the pre-commit, we're going to do a synth. So from a CDK perspective, we're going to synthesize the full application, which will then make CDK NAG run. So with CDK NAG, we're going to do all of those checks at that kind of stack level. Now we haven't got something like a bucket that is publicly accessible, that kind of thing. And we've also got formatting. So you can see we're using Prettier to make sure that all of our code's formatted before it's pushed through. We're running lint, so ESLint. So we're going to do those particular checks, and we're also going to run on the pre-push. We're going to run our unit tests from a Jest perspective. So that's very high level, the kind of local development aspect.
How long does these two steps take? Kind of, can you say that?
Yeah, so these are very, very quick, super quick. You're talking a second, maybe 2 seconds to kind of run through these, depending on obviously how many tests you've got and things like that. But with this particular repo, very quick. With the cloud services that I work with and the teams I work with, again, 5 to 10 seconds max in my experience. Okay.
Yeah, just asking that because I've seen pre-commit hooks taking 30 seconds, sorry, not minutes. And that's where I, as a developer, become impatient, right?
Yeah, that is true. Yeah, so the teams I work with, pretty quick. And then we've got the source stage. This is your actual pipeline itself. So very high level, you've got the source stage, which from our perspective is the cloud assembly. So typically when you build a CDK application and you do that synth, you get the CDK out folder, and that contains everything that your pipeline needs to actually do the deployment. You've got the build stage. So you're going to run through very similar things that you've done at the engineer level. So you're still going to run your unit tests again. You're still going to run all of those kind of quality gates. You can see here unit tests, ESLint. It's going to run CDK NAG and what have you at that point. And we're going to package all of the various artifacts as part of that. And then as we kind of move through to, in this particular repo, I've called it feature dev, but in this paper, it's called beta, where we do things like database deploys. So in this code repo, the way I do that is using custom resources. So as you deploy that stack as part of this pipeline, it will ping up a Lambda function, essentially, that is going to do things like creating your master data. So in this example that I've got in this particular repo, it is writing some records for stores, because this example is where you can buy from particular stores. So you've got London, Newcastle, Manchester, and it's that metadata that you need. And I think what the key thing is here as well is when developers are spinning up ephemeral environments, again, which this article covers in this particular setup, I might want to just create a quick, fully fledged repo, fully fledged deployment, which has the client application, the backend systems, it has all the feature flags, but just specific to me. So it could be I create a PR or particular ID for a Jira ticket or whatever it is, that I can spin up that application. And with that, you'll get all of the domain names and subdomains set up. So things like PR111 dot, whatever your domain is, .com. So I can do all of my work in that, and then I can tear that down when I'm done. So that is one of the key aspects of this. But that database deploy means that you don't have developers, which I've seen so many times over the years. To create your own environment, you have to start running scripts to do this and to insert data, and it's an absolute nightmare.
Yeah, I cannot agree more. So kind of the possibility to deploy a sandbox environment for developer purposes, I think is really crucial. Especially in, I don't know how you tackle that, right? But in the cloud development experience today, a lot of things rely on testing on the cloud itself. It's really hard to test locally. Or how do you test your stuff locally, right? Of course, use it unit tests. You mentioned that, but can you test the serverless stuff that you do?
So typically, this is where the ephemeral environments have come in for the teams I've worked with. So over the years, we've tried things like local stack and things like that. But as you move more to these bigger applications in an enterprise that have a lot more external dependencies, and you've got things like EventBridge as your central event bus, and it just becomes a nightmare, and you spend more time actually trying to configure everything locally as opposed to just deploying what should be very, very quick from a serverless perspective to spin up this environment. You can test it in the cloud as a customer would, and then tear it down afterwards. So that is very key with the database deploy. But you'll also see here that we've got things like integration tests. In this particular repo, it is using Postman and Newman. So for anyone that hasn't looked at integration tests, that is testing things like API Gateway. So we might go and create an order, and then off the back of that, we might go and get the order using these API tests. But obviously, there's a lot more you can do. So as part of this code repo, it tests hitting endpoints with bad payloads, and you might assert that you get a 400, for example, or you might also want to assert that the actual payload coming back is in the right shape, the right content type, and what have you. And you can see we've got acceptance tests. So like I said before, we can see on the left here, we've got the client written in React, and we're using Cypress. So in this kind of beta stage, we are running through the front end using a headless browser and clicking through as a customer would using that front end, which is going to exercise the full stack, because obviously it's the client hitting the API, which is then interacting with all of your databases and what have you under there. So that's the kind of beta stack. And then that moves on to the Gamma side.
One more question on that one right before. So we mentioned ephemeral environments. These are obviously not created by the pipeline. They need to be created by the developer locally, right?
That's it.
Okay, cool. So that means when passing the gamma stage, the beta stage, we have already verified in an integration environment that our code changes are good to go. Is that correct?
Yes, so these would have all have gone straight through the, to production. The developers, created their own ephemeral branch at that point. So everything should be kind of good to go. You're right, it doesn't go through the pipeline. At that point, the developers, running a NPM script so if we look on the left-hand side here, actually, what we'll say is there is a .env file. And what this is going to do from a pipeline perspective, which is still part of CDK pipelines, but it's not going to run through the pipeline, is create these various stacks with the right environment variables. So we can see here PR888, which is fictitious, but what this would do is create, like I say, PR888 for the front end as that subdomain, but also the API, which is sitting behind that. The developer can still run all of the same tests from a Cypress perspective, or the integration tests, just by running those NPM scripts. But once it is backed in, it will be exercised again through the full stack, full pipeline.
Okay, and the project structure is set up in a way that you have one repository for everything that you need to have an end-to-end solution deployed, right? So it's kind of a mono repo because you have backend services and front-end services in the same repository. Is that right?
It is, and the reason for that, so we can see on the left-hand side, we've got obviously the client, like we said, but as part of this part here, you can see you've got the notion of an app, and that app is made up of a client stack, a feature flag stack, a stateful stack, and a stateless stack. So as a particular workload that's being deployed through end-to-end, this is that full workload, the client on the back end and the feature flags. And that helps massively when we do come through this pipeline, because a change that's committed either to the client or to the back-end service independently, that is going to run through the pipeline and do the integration tests, which are more back-end, and the acceptance tests using Cypress, which is obviously front end, which exercises that full stack. So we don't get into that scenario where the client is in a completely separate repo, the backend services are in a different repo, they run two pipelines independently, but changing something in the backend API could affect the client and vice versa. So very quickly if a change in one of these has affected this particular pipeline. So a lot quicker, essentially.
Okay, cool, thanks. Cool, so that means going back to the beta stage, after the beta stage, we now have deployed something like a beta environment, right? That is actually functional and running, correct?
Yeah, that's right. So we have our feature dev environment in beta. We come through to staging, and here we have some of the longer running tests in here. So again, we do the database deploy for that kind of master data that we need. And as part of that, you can also run things like migrate Mongo and other, frameworks that are going to do things like schema changes and things like that. And if you do that, obviously with a custom resource, you need something in there like a UID as part of the payload. So it runs that custom resource on every stack deploy. That's a little bit of a trick that I've done in the past. But it's also going to do things like synthetics. So it's going to run synthetics tests using things like CloudWatch synthetics. That's going to run in this environment. And we're going to do performance tests. So on the left here, you can see we've got load tests using artillery. And this is where it takes a lot longer, because you might run these tests for, it could be 10 minutes, 20 minutes. So as you kind of progress through this pipeline, you want to know quite early on the things that are definitely going to fail. Obviously, when we run the integration tests, acceptance tests, the longer running things we want to run, obviously later in that pipeline.
And this would also potentially be a place where we could now integrate chaos engineering in that gamma stage at the end, right? So trying to break the environment would be part of that testing phase, I would say.
Yeah, and maybe that's a part 5 to this article. Maybe that's something I'll pick up on. That's a good shout.
So this is the second time you mentioned the article, and we missed that in the introduction, right? So yes. We're going to add to the show note a very fantastic a series of articles that Lee has written around this topic, which I believe also includes code changes, right? Code samples, right?
It does. It covers over 4 different articles as part of a series, how you actually build up to essentially build what we have on the right. And that's all in code. People can pull that down, deploy it, play around with it, and debug, and just see how it all kind of works together.
Cool. I'll make sure to add that. Fantastically written. Thank you so much for that. On the Keras engineering pieces, I'm soon going to have Gunnar Grosch as well on the show, where we're going to talk about Keras engineering in the CI/CD pipeline. So that's also going to be an entertaining session, and then we can maybe get that back into that open source project that you have over there.
Amazing. Yeah, definitely. Sounds good.
So we're done with the Gamma stage. We're done with the testing on a Gamma environment, and now we're ready to go to production, right?
That's right. So what I have done in this example is added a manual approval stage within here to mimic. Just to show how to do it more than anything, because it was on here as this kind of guidance of best practice. I thought just to show people how to actually do that, let's just get that added in there.
Okay. Would you do that in your projects?
It depends on the companies, I think, the organizations I've worked with. A lot of organizations still like the idea of a change board, and things like continuous delivery, continuous deployment is quite difficult. So it gets to that stage, and I think that final confidence that everything's running fine, they like that actual manual improvement. Some manual approval, I should say. Some organizations I work with, it's just straight through all the way to production.
Yeah, that's true. But I was just curious, right? How you're gonna do that? Okay, so we have that manual approval step, and then the same thing starts again that we did on lower environments, I would assume, right?
Yeah, so we don't run through all of the load tests again and things like that, but we do the database deploy for the master data. And at this stage, from an AWS perspective, it's only here where they talk about progressive deployments. So again, in this example, I'm using Lambda progressive deployments, so doing a canary of 10% to start with, and then after 5 minutes, rolling out the other 90%. Now, if there are errors using CloudWatch alarms in that time, it will fail the pipeline. But the organizations I work with, we actually do the progressive deployments also at the Gamma stage. That is just what works for us. We like that confidence that that particular setup around the progressive deployments isn't just done at a production level. When it hits that stage, we like to make sure that that's actually going to work. So we do that at the Gamma stage as well. And yeah.
Maybe, so let's tie this comment back to a recent event that we had this week. I think we had a bigger outage at AWS in US East. It feels like they did not do that progressive deployment for a certain feature that they did, or what do you think?
No idea, to be honest, because it could have been an infrastructure issue or some kind of networking issue. It might not have been at a feature level if it took down a full region, but who knows? I've not seen the actual underlying reason for that. So I think it affected multiple services. So I would imagine it was bigger than a feature, I imagine.
Would your progressive deployment approach here avoid this service from going into the same problem?
It would prevent, say, a Lambda function. We've added some code in there which, I don't know, has some kind of bug in it. It would at that point, and not at the prod stage, but at the Gamma stage. In this particular example, we'd find out very quickly with that 10% that's kind of pushed out into prod, into that actual environment. Are there any issues with this particular Lambda? And then obviously after that period of time, I've got it down as 5 minutes. You can extend that. That's obviously just what I've put down. We would know before we then throw out the other 90% of Lambdas and move up to 100. So I guess it depends on what the underlying issue is. If it was networking, definitely not. Or if it was permission-based, no, at that stage, because this is just a Lambda progressive deployment.
Okay. Thanks. What about something like a smoke test after the deployment? Is this what happens in the synthetic tests, or do you run Cypress tests again on production, or not? How do you do that?
In this particular example, there aren't any smoke tests, but you could use, again, something like artillery. It's not just for load testing. You could run smoke tests with that. Obviously, you could do the same with Postman. You could add that to this particular kind of prod stage. The synthetics example I've got is one very basic API based synthetic, which just hits every minute the get orders endpoint and returns the orders and ensures it's the correct kind of status codes. The visual one is more for the kind of divergence. So it says if there's a variance of more than 5% on this particular page, then again, throw an error and kind of alarm on that, so that, you know, we would get an email to say there's some kind of issue. And in my experience, that's typically when something like an API is down and your client application, when the Visual Canary hits it and tries to run it, you might have a big error bar, or you might have a modal come up that says an error's occurred, whatever it is that causes that variance. But again, this example, because there's so much to get into one code repo to show what we're doing on the right-hand side, it is just two very basic synthetics: check an API endpoint and check the visual variance of a web page.
Yep, awesome. That sounds like an end-to-end solution. We have now looked at the diagram. Can we see some code?
Yep.
We're already in 27 minutes, but I think it is worth looking at least a little bit into the code. So Lee and I had so much to talk about that the session got a little bit longer. For publication purposes, we decided to split this session here. So stay tuned. The second part of our conversation is going to be available in the next 3 days.